I'm Stefano Martorana and I work at Leonardo Aircraft Division in Turin. I'm in charge of research and innovation projects. The scope of the challenge is the development of a ground tool to support the management of a fleet of drones. Basically, the system, thanks to artificial intelligence algorithm, shall be able to support the ground operator, minimizing his workload in the management of the fleet in case of replanning. The replanning could be due to a new task assignment or a new team composition.
Imagine a man that is hiking through the forest and meets with an accident. Typically, it could take up to 4 days before he is found and rescued, posing a great danger to his health and potentially even his life. In fact, over the last decade, nearly 345,000 people have lost their lives just because they could not be found in time. That is the equivalent of the entire city of Florence being wiped out in just 10 years. Additionally, another 214,000 people are still missing or completely unaccounted for. These figures really highlight the serious limitations in the existing solutions that are adopted in these scenarios. Traditional search and rescue methods, such as employing trained men or dogs, only work well with static targets and often imply a certain level of danger to the operators themselves. Meanwhile, each single drone needs to be continuously piloted by an operator on the ground, making them very difficult to manage. They're also fairly limited in the distance and duration that they can cover. Neither of these solutions satisfy the speed requirements of this particular scenario either. But then there has to be a better solution to this problem, a way to avoid this loss of innocent lives. That is exactly what we set to find out at Space Tech. Over the past few months, we've been working with Leonardo, which is one of the largest aerospace and defense companies in the world. Together, we have developed an integrated system that can autonomously pilot a fleet of drones to achieve this mission with minimal human intervention. To develop our MVP, we started by conducting detailed interviews with the organizations that conduct these operations themselves. Based on this, we identified the core requirements that stem from both the scenario and the technology that we have adopted. In particular, the search and rescue scenario requires a fast, accurate and clear solution. Meanwhile, the fleet of drones must work autonomously, collaboratively and efficiently to achieve their target. The interviewees also highlighted the importance of an easy-to-use solution that can help reduce the stress on the operator in these critical times. We translated these core requirements into 3 key functions that our system must be able to deliver. We must have an intuitive interface that allows the operator to set the mission parameters as well as receive feedback from the fleet of drones itself. The system must be able to organize itself efficiently and manage failures whenever they arise. Let's look at a quick video to understand how we fulfill these functions to help save our friend in need. As soon as the authorities get to know of the situation, they can jump right into action. The operator starts by choosing the fleet that he wants to use and defining the area to be scanned. He can also define sub-regions to be scanned by a specific sensor. For instance, he might prefer using the infrared sensor for the deeper foliage. Next, he defines the characteristics of the human using the predefined library. And that's it. The system will automatically design, run and manage the entire operation and alert the user in the case of the failure of a drone or if it finds something interesting. That is the power of our solution, to be able to convert an inherently complex problem into an elementary 3-step process that makes finding people faster, easier and safer. The real magic of our solution, however, lies under the hood, in our proprietary fleet management system. This system takes as an input the area that was defined in the interface and runs an image processing algorithm to generate a correlated matrix. This is then passed on to the cost assignment algorithm, which divides this area between the different drones according to their respective capabilities. Finally, we run a genetic discretization algorithm and an optimum path planning algorithm that helps us identify the most efficient and economic route for each drone. And all of this happens at an incredibly fast pace. To put it in perspective, for a 1 square kilometer area, it takes us less than 30 seconds to go from the input from the user to the start of the mission when the drones can take off. In the next step, we aim to make our system even more robust by implementing a system that can autonomously manage low battery situations as well as pre-process the data before it is delivered to the user. Our main focus will be on building a system that can automatically detect and diagnose failures and even replan the entire mission if needed. We are a team of engineers and architects from the Alta Scuola Politecnica. Cumulatively, we are skilled in not just the physical behavior of the drone, but also in the coding and cartography aspects of this problem. Together, we are on a mission to help save lives. Thank you.